has one extra material in there. So it's asking to identify and classify local extrema. That's either first derivative test or second derivative test. Local extrema is what? Either first or second. Or the second. What about the absolute? The absolute is the extreme value theorem or closed interval method. This one is that you need the continuity and closed interval. The conditions. This is asking for both of them. One of these and one of those. Sounds good? So now, one of the reasons these questions are of value is because there are not only points that make the derivative zero, there are points that make the derivative does not exist, but the extrema may or may not exist on those points. So the critical points are of both types, basically. So that's why the third root is, okay, before I start this problem, what is third root of -8? -2. If you put it in your calculator, it gives you error. Because it depends on the calculator. Better calculators doesn't give you error, but you don't have that better calculator on the exam. So you have to remember that this is going to be equal to negative third root of 8. With third root, negative comes out. That's all. Fair? Okay. So now let's start. So I have f of x equal to x to the power 1/3 times 8 plus x. And I'm trying to take the derivative of that. One way is to do the product rule. The other way is just to multiply it in and then do it. Which one should I do? Product rule? Okay. So f prime of x is equal to, are we just avoiding that adding the exponents? Is that it? So 1/3 of x to the power -2/3 times 8 plus x plus x to the power 1/3 times 1. Now, so what is this? This is 8 plus x divided by 3, x to the power 2/3 plus x to the power 1/3. Now, common denominator, 8 plus x. With common denominator, these two multiply, plus 3x over 3x to the power 2/3. Is everybody okay so far? Are you guys okay? That part was okay? The common denominator. Multiply x to the power 2/3 by top and bottom of that. 3x to the power 2/3, 3x to the power 2/3. X to the power 2/3 times x to the power 1/3 is x. So now I'm factoring out 4, 2 plus x over 2 to the power 2/3 and 2 plus. Which one? This one? That one is 2. No, it's 3. Thank you. Okay. Yeah. So 4 times that times 3 x to the power 2/3, which I can rewrite it the way that is there, and that's this. X to the power 2/3. So far, so good? Okay, now let's do identify and classify the local extrema. So identify and classify. First one is find the first critical points, right? So let's find the critical points. And critical points here, one is the 0 of the numerator, 0 of the function of f prime is x plus 2 equal to 0. That's x equal to negative 2. Then f prime d and e at x equal to 0. Wait a minute. Is x equal to 0 in the domain of the original? Can I plug in 0 in the original? What do I get if I plug in 0 in the original? I get 0, right? So it is part of the domain. This is the one of the examples that you can see that the points that f prime doesn't exist is part of the domain. Some of the examples that we gave so far may not have been that way. So that one is still part of the domain. I say when you get to this part, you are better off doing the first derivative test already. So we're doing first derivative test, not second derivative test. Sounds good? So x equal to negative 2, 0, f prime. What is f prime? F prime is that. Okay, so here's the deal. If I have a very negative number, right? Let's put a negative number. Oh, I'm sorry, negative, more negative and then negative 2. So now I can do the test points, right? So far I wasn't doing the test points. But I can now do the test points. So I do, let's say, negative 8. If I plug it into the f prime is what? 4/3 of x plus 2 over x to the power 2/3. So f prime, negative 8 is going to be 4/3 times negative 6 divided by 4. So it's a negative value. All right, so this is the test point. Something in here, negative 1. Plug in negative 1, the numerator is 1, the denominator is 1 times 4/3. It's a positive value, test point. Then something positive, 1 is a good positive number. I'm choosing the ones that have a third roots, basically. And so if I plug in 1, I get positive on top, so it's positive test point. These are critical points. Now I can see it's decreasing before the critical point, increasing after critical points, and increasing after the critical points. Right? So with this question, what do I have? I have basically, yeah. With this question, I have a bottom of the valley, but no top of the hill. Right? No top of the hill. So I have f has a loc min at x equal to negative 2. That's it. All good? It felt like you're doing the floss. It looked like a floss. Floss? I don't know how to do it. So, it did look like, I don't know. It's like, oh, are we doing that? Okay, so that went out of style very quickly. It was a good dance for a while. So now part 3 of it. Part 3 of it, and I want to find the absolute extrema. So absolute extrema is f continuous on negative 27 and 0. Yes, we can plug in whatever. It's everything okay. This is part of the domain. domain of f is everything basically. Again, because it's the odd root, it takes everything. If it was the even root, it wouldn't take the negative values in. Odd root takes everything in. So domain is everything. So now, so EVT, check. Close set and that. Now, let me write closed. Now, find absolute extrema. So what I do is I have to find the critical points. I already did that. X equal to 0, x equal to, what was it, -2? Right? So I have 2 critical points, and I have 2 endpoints. Oh, darn it, these 2 are the same. That's okay. Right? So endpoints, critical points. Critical points, that already has points in it. Right? So between these, I have to check x and f of x. 0, -2, and -27. Plug in 0 in there, you get 0. Plug in -2, and you get, you get negative square root of, the third root of 2 times 6. And plug in -27, and you get negative third root of 27, which is what, 3 times a negative value. What is that? -19. -19, right? 27%. So that one is negative and negative simplified. That 3 comes out because 27, 2 to the power 3. And so I get 3 times 9, 7, and wait, yeah, 5, right? So that's a nice one, and that's a max. And this is less than that, so this is a min. So min at x equal to -2, and the value is -6, third root of 2, max at x equal to -27, value is 57.